Okay. I recommend when you have, for example, a variable t, it's much better doing by calculus, so that you differentiate. However, when you have numerical value, okay, you maybe are doing using the Frenet reset formula, in which you compute dot product, cross product. Let's see in the another example. But in this example, it's much better differentiation. You find the first derivative. The first derivative is derivative sine. You apply the chain rule. Entonces, in the chain rule, derivative sine es cosine. Pero, of course, you differentiate the argument, que es 3t squared. So, actually, it's 3t squared cosine tq. Everyone following? You understand very well this is the calculus 1. And derivative, the second component is 3t squared. Comma, and derivative sine minus derivative cosine, sorry, is negative sine. And derivative the expression inside the argument is minus 3t squared sine tq. Everyone follow me so far? Yeah. Okay, 100%. Take care. Okay, now I propose you, why not compute the magnitude of this vector. Now, what is the reason? Because remember the formula. The tangent unit vector is equal first derivative of the position vector divided by magnitude of the derivative. Okay, remember the interpretation of this guy is velocity. The interpretation of this guy is speed. The speed is scalar, entonces es square root. This guy is square is 9 t4 cosine squared t3 plus 9 t4 again plus 9 t4. When I don't care que es negative because we square become positive, sine square tq. Okay, and we can simplification. Of course, we can simplification because I can see que 9 t to the 4th power is a common factor. I factor out. I factor out inside the radical o I factor out outside the radical. Entonces es actually 3t squared, ¿no? Make sense or no? I'll stay alive inside the radical 1 cosine, this is 1, and 1 sine. I know the famous trigonometric identity que cosine squared plus sine squared is 1, and this together is 1, and 1 plus another 1 that we have here is 2. And so far the answer is the magnitude is 3t squared radical 2. Okay, good. Now if you want to find the tangent, the unit tangent vector. Actually, my goal is the unit normal, but okay, I need to compute first. This is the, it's the chain. Like I have R, I find the unit tangent, and after I find the normal. Okay, my final goal. Okay, so you divide this by this. So when you divide this guy divided by this, it's obvious que 3t squared is cancelled and divided by radical 2. So my unit tangent vector, unit tangent vector look like that. Is cosine tq divided by radical 2. Remember, this and this cancel out. Look, and also cancel out with this, and also cancel out with this. Comma 1, comma minus sine t cubic divided by radical 2. by radical 2, no? Yeah, by radical 2. And here divided by radical 2. Sorry. Okay, in my paper, I confusing because I copy in that way. Look, I copy 1 over radical 2 outside the vector. So you have cosine t cubic, comma 1, comma minus sine t cubic. I think no, this is a unit tangent vector. In order to find the normal, okay, the formula for the normal is one possibility. There are a lot of formula in the Frenet-Serret formulas. Is you divide the unit tangent divided by magnitude of the unit tangent. It's a one possibility. I prefer this way because we continue using calculus. And you know, the function involved in my problem is trigonometric function, sine and cosine. And sine and cosine are cyclical. Derivative sine cosine, derivative cosine minus sine, derivative minus sine again cosine, 1 cosine, whatever. This is no big deal. It's super easy to do it that way. However, if you apply the geometry idea, cross product is complicated to determine using that function, derivative. Wow, it's horrible. Okay, so let's doing the derivative. So this is like a function of t. No? This is like a function of t. Derivative is. But actually, we differentiate this guy. When you differentiate, well, if you want the radical 2, I put out completely because it's a constant, and you differentiate component by component, no? It's minus 3 t squared sine t cubic. The derivative of this was similar to this. No, exactly, but it's cosine. Derivative cosine is minus sine. Derivative 1 is 0. It's a constant. And derivative sine, negative sine is negative cosine. Well, derivative sine is cosine, but we have a negative 1 in the front. This is minus 3 times t squared cosine. Cosine t cubed. This is the vector that represents the derivative of the unit tangent vector. Okay? And now you find the magnitude. You find the magnitude of this. You know, this problem is no big deal, but it's too long. It's too long. So I recommend you are doing step by step. No? So the magnitude of this is, well, this is the constant stays the same. And the magnitude of this is square root. This guy square is 9t squared sine t cubic square. So this is not square, 4. Sorry. It's minus 3 square is 9, t square is 4, t to the 4th power, and sine square. And 0 square is 0. And this is all is negative, but when you square positive. So it's exactly the 94 cosine square t cube. Again, I can see 90 to the 4th power is common factor. I factor out inside the radical, and outside represent 3t squared. So the answer is 3t squared divided by radical 2. And stay inside sine plus cosine, que es 1. And square root 1 is 1. Okay, now when you divide, so the final answer, the normal unit vector for any time is this vector divided by this magnitude. When you divide, it's obvious que 3 radical 2 disappear and stay alive and t squared disappear. And you cancel out, so stay alive, only minus sine t cubic, comma 0, comma minus cosine t cubic. And it's my final answer. So basically, let me see. When you divide this divided by this, it's obvious that radical 2 is cancelled out. This 3t squared cancel out here and here, and stay only sine with the minus here, minus 0 and minus cosine. Any question? Super. We can do using another formulas. In my paper I'm doing, but it's too long. Okay, just algebraically. So my recommendation is when you have the function easy, like sine, cosine, using calculus. Any question, guy? I want to hear opinion. Is it hard, complicated? No? No? Opinion? Decent. What mean decent? Is no 100, it's 85%. Not bad. Just long. Yeah, I know. Yeah, I try to select 92. Okay. Okay, let's go move into the seventh question. Seven question say seven. Seven say it's a typical projectile motion in 3D. If the rock is thrown into the air near the Earth's surface with the initial velocity, let me copy that. Initial velocity is velocity at t equals 0. It's a vector in 3D. It's 16,0,64. The unit, because it's a physical problem, to the feet per second. What means that? Well, it means que velocity null en x es 16. Velocity null en y es 0. And velocity null en z is equal to 64 feet per second. So this is a component for the initial velocity. You can write like that, or you can write like that. V null. V null like a vector. Okay, this is my first piece of information. My second piece of the information is, and the initial position is displacement position at 0 is also vector is 0, 0, 6 and feet, only feet. Okay, entonces the rock is launched in one specific position, x, y, z. No x, no y, and 6 feet. 1, 2, 3, 4, 5, and 6. This is the initial position, and I suppose that we have a parabola. The typical projectile motion exactly the same way studied in physics, but the only difference is that in physics normally you study in 2D, not in 3D. But it's okay, it's the same. But the third piece is given is acceleration. Acceleration is acceleration to any time is equal 0, negative 32 feet per second square. Okay, so this is a typical problem in which I go back because no derivative, it's anti-derivative. So the only information that we need is, well, the only, look, this is the initial 0, 0. But this is for any time. The acceleration is the same because the acceleration point down. Because this is free fall motion. And the only force that participates in this game is the weight, is the gravity. This is the gravity actually. Okay, so we compute the antiderivative. So if you want to retrieve the velocity function, you integrate the acceleration, antiderivative. It's a vector, no? Entonces, the antiderivative exactly the same. We are doing component by component. We are doing component and component. Derivative de 0 es constant. Pero what constant? The initial, que es 16. Make sense or no? Likewise, derivative 0 es constant, pero what constant? Bueno, in this case 0, because we have no velocity in y direction. And 64 in antiderivative is this 32 minus 32 minus 32 antiderivative t linear plus a constant, and the constant is the initial velocity in the z direction, que is 64. Okay, and we have in my hand now the the vector value function que represent the velocity, no? It's a feet per second. Okay, now position, exactly the same. Again, we are doing the antiderivative. Antiderivative velocity, give me the position, no? Entonces we're using the famous idea of the vector value function. You see que fantastic this idea, guys. Because in vector value function, you condensing in only one mathematical object whole information of the three components. Entonces you integration, antiderivative, 16 is 16 t plus something, plus the position, but the position is 0. Remember here, my point was 0,0,6. And why we have no velocity, we have no position, to say why stay 0. Here your integration, integral of this is 32, go outside, integral t is t squared divided by 2, no? Entonces es minus 16 t squared, antiderivative 64 is 64t, plus a constant, que the constant is 6. Okay, and this is the vector value function que represent the position at any time in our predictive motion. Okay? Okay, entonces this is the parabola, ¿no? Es obvio que es de parábola, look, es parabolic. Because the height, que z, is parabolic, right? Entonces they want to know, compute the maximum height with the rock and the maximum range, and remember the acceleration of this. O sea, this is a parabolic. Entonces I take about an algebra. Yeah, I know que this component is z, que es de parábola, es minus 16 t squared plus 64 t plus 6. And I know que the vertex of this parabola, of this parabola occur at the point minus b over 2a. I suppose que you remember very well that formula, no? Call it algebra, minus b over 2a. Minus b is 64. Okay, it's a quadratic equation, no? ABC, no? And divided by 2 times negative 16. And of course, the number que give me here is 2. Okay, double negative become positive, 32, 64, 2, represent the time, que es 2 seconds, ¿no? O sea, at t equal 2 seconds, the parabola, o sea, the parabolic motion, get the maximum value, no? If you want to obtain the position in this, bueno, it's easy. You evaluate r, the position function, in 2, at t equal to 2 seconds, no? What this one? Entonces 32. The maximum is 70 feet. Yeah, you are right. Okay, you are right. And 2 is 32,0,7. Yeah, you are right, Ricardo. O sea, when you plugging in t equal to here, 2 square multiplication by this, 2 multiplication by 64 plus is 77. This is the feet. Entonces I can see clear que le componen y, que the maximum of the parabola is 7. O sea, the maximum height in this projectile motion, maximum height is 70 feet. Okay. Now what about range? Bueno, range is when the parabola, o sea, when the rock hit the ground. And when the rock hit the ground is when the c is 0. So I need to investigate When this expression gets z, this expression should be 0. Entonces sí, you solve the quadratic equation. Minus 16 t squared plus 64t plus 6 equal to 0. I don't want to explain quadratic equation. No? I suppose that you know very well. And the answer is t equal approximately 4.09 seconds. Okay, obviously it's a time a little bit bigger than this, no? Because this is a moment in which the high is maximum. In this case, no. In this case, when the high is 0. When they hit the ground, you stop here the motion. Now, if you want to find the position, so the maximum range I suppose que es this time. Entonces, you plugging in this number into the position vector, and the position vector to any time is this, no? This. Entonces, position vector, evaluate at the famous point 4.09 is multiplication 16 times something is approximately 65,0,0. Remember that this number when you plug it in here, c is 0, y always was 0, and this is 16 times something is 64 point something. I round to the 65. Therefore, the maximum range is approximately 65 feet. Any question? Professor, I have a question about different topic. Bueno, no, pero yo I am a teacher, ¿eh? Entonces, okay. Okay. Listen to me. This is the review. I am doing the problem of the review. So you have extra question. It's okay, but the order, I stay the order. No your order. This is my class, not your class. Okay? After you can ask me anything. Don't worry about this. Well. No. No, I know que you are nice. I know. It's a simple. Bueno, it's a simple question. It's okay. Annette, come on, go ahead. Entonces, could you stay when the class is over? And do show our calculation for the cross product point be deducted. Yeah. Of course, yes, you can. But it's too hard. Okay, Annette, stay when the class is over. Entonces I try to explain your idea. Okay. What is the next question? Okay. What is the next question? The next question is about sketch the graph. Uy. Look at that. Number 8. Number 8 question say sketch the graph in 3D, of course, of the following quadratic surface. They want to know the name and their property. Okay. 4x squared plus 4y squared plus c squared equal ay. Entonces, the first thing you should do is the identification. This guy, what is this guy? This guy is ellipsoid. This guy is paraboloid. This guy is hyperboloid. This guy is a cone. Opinion. Come on, opinion. Opinion about that. Opinion. Name. Elliptical paraboloid. Okay, good. Look, maybe the confusing part, you see, wow, we have a linear here. No, I don't care, because when every variable is completed, x, y, z, and all are squared, es obvio que es ellipsoid. I am confused for this pretest. What pretest? We are doing the review. Study guide, Anne. Do you receive, Anne, the study guide or no? Gotcha. 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 Okay. Yes, sir. Okay. Entonces we are synchronized. We are doing well. Number 8, send to the test. I send both, Ricardo. And you know, you are smart people, and you see that they are coincidence with some question, huh? Okay, this is one more thing I create for help you. Okay? Gotcha, gotcha, gotcha. Okay. Okay, okay. Entonces now, in order to understand, ellipsoid, ¿no? Es the name of this guy, ellipsoid. Ellipsoid, yes or no? Everyone is agree? No paraboloide, no, es ellipsoid, right? Look like a football, ball, no? Uh-huh. But it's important, for example, to determine exactly what the center of this ellipsoid, and some traces to understand a little bit much better, right? Okay, so I need to manipulate. For example, this y, what is the interpretation of that part? The interpretation is, can we have some motion, some shift in the y direction? When you see combination quadratic and linear, so suppose the y, I move ay to the left. By the way, I factor out 4. So we have y squared minus 2y. When you move ay to the left, it's negative 8. When you factor out inside the y part, 4. Now, in order to complete the square, I put a box here. C have no linear. That means equals 0 for a moment, no? Plus a box. And the famous number that we need is 1. It's obvious, right? Remember the idea 2 divided by 2 is 1, square is 1, is 1. Actually, when you introduce artificially 1 here, actually 1 times 4 is 4. Everyone follow me so far? The organization of this? Ready. Entonces 4 x squared plus 4 y minus 1 squared plus c squared equal 4. I'm going to express it in standard. You divide everything by 4 because the right hand side should be 1. So we have x squared plus y minus 1 squared plus c squared over 4 equal 1. Okay, entonces identify perfectly my ellipsoid because the formula in standard for the any ellipsoid is x squared divided by a squared plus y squared divided by b squared plus c squared divided by c squared equal 1. A is 1, b is 1, and c is 2. It's square root 4. Now, I know that the center of this ellipsoid is located at the point 0, 1, 0. Okay, 0 because it's 0 here. No, we have no displacement. We have no shift in x. We have shift only in y. To make sure everything is okay or no, we're doing the trace. Suppose z equals 0. Suppose c equals 0 on the original equation. C equals 0 on the original equation. We have x squared plus y minus 1 squared equal 1. Es elixir. Es elixir, no. It's a circle. It's a circle. This is the axis. Look. This is x, y. We have circle. And the circle, the center is located at the point 0, 1. 0, 1 here, I suppose. 0, 1 here. And the radius 1. So my traces look like that. Boom. Make sense? When you are doing the graph in 3D, of course we can use in decimals. GeoGebra, sorry. One more. Suppose another trace. This is circle. Now suppose x equals 0. And the original equation, entonces y minus 1 squared plus c squared over 4 equal 1. Es obvio que es el x. This is yz. Yc, es obvio que a es 2, es obvio que b es 1. And this elixir lie on the z-axis. So now we have 2 here, 1, 2, and 1 here. 1, 2. Our elixir look like that. This is 2, negative 2. This is 1, negative 1. Sorry. This is wrong. No. Okay. Because I forgot the center. Okay, the center. Okay, this is 1. It's okay. The center is located one more time at the point. Bueno, actually it's this point, ¿no? Pero when you omit the x, es 1,0. Ok, entonces es 1,0, es 1 here, 0. Entonces, again, the same idea is a is 2, and this is 1. Entonces, my elixir look like that. At this point, is the point 1,2. This point is 1, negative 2, no? This point is, this is 1, no? This is 2,0. Because of 1 in this direction, and 1 in this direction, this point is 0,0. Okay. Everyone follow me or not? And suppose now y1. Okay, suppose y1, no 0. Suppose, well, you can, of course, but I'm using 1y because my intention is to delete that part. So it's x squared plus c squared over 4 equal 1. And remember, the trace is any arbitrary plane. So in 3D, my first trace was c equals 0, que es xy plane. My second is x equals 0. X equals 0 is the zy plane, cy plane. But the next trace is y equal 1. Y equal 1 is a plane like that. Like that. Okay, passing through 1 here. Don't. I discover que in this we have another elixir. Elixir que A is 2 again, B is 1 again. But we have no translation because actually I did translation here. Guys, doesn't matter. This is one possibility to analyze this. Entonces now in my famous XC, remember I put C always in the vertical position, and when you have X and Y, you put Y in the vertical position. This is one way, no? Entonces es elixir. What kind of elixir? Well, I suppose que es something like that. 2 here, minus 2, 1, and 1. And the major axis lie on the z-axis. Okay, entonces, bueno, okay. I suppose que the trace look like that. Okay. Now I try to do my best by hand. Okay. And in the test, no. In the test, you go to the GeoGebra, try to do the. When I want to see in the test on paper, you show me your work in detail, no? Not necessarily in this way I am doing, in your own way. This is X, this is Y, and this is Z. So I discover, for example, okay, in this axis, okay, we have a circle like that. circle, 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 like that. This circle is this. Okay, so you rotate. It's obvious, right? We have elixir. And the elixir is okay. Let me try to do my best by hand. One elixir like that. Bang. And another elixir like that. Bang. Okay. And this is my ellipsoid. And the answer that you send me, you try to do in GeoGebra. And you there are one option in which you share the graph. So you convert the graph that you have in your computer like an image. Okay, and send me back the image, right? It's easy. You click in, this is the traditional way, no? You click here, share, and to say you select the like a picture or like a copy in the clipboard, and after you paste in another application, whatever you want, using your imagination. Any question, guys? Any question? No. Okay. Okay. Okay, good. Next question is number 9, no? In number 9, we have 3 vectors. U, B, and W. And they want you prove using the triplet scalar product to verify that the vectors are coplanar. Coplanar means lie in the same plane. Okay? Easy. Guys, you follow me? Everyone follow me or no? Any question? This is the review. This is the moment to ask me a question, no? Okay. Okay, and the question number 9, we have 3 vectors. U vector, que es el vector 1, 4, -7. The vector B, que es el vector 2, -1, +4. And the vector W, que es 5, 9, -4. Okay, super. Now they want to prove somehow that these 3 vectors, or actually this, so you interpret this like a point, 1, 4, -7, no? And so on. This is another point, 2, -1, 4. Okay, the only thing you should do is remove the angular bracket to parentheses, and this is the interpretation as a point, called P point, Q point, R point. 5, 9, -4. Entonces, I want to prove that this point, in the 3 dimensions are coplanar or no. Coplanar means they belong to the same plane. So there are many ways to prove this. Using the scalar triplet product, in which, for example, you select 2 arbitrary, you have 3, no? And you pair 2 vectors. Suppose that I pair U and B. And you perform the cross product. Okay. When you finish to perform the cross product, you are doing the dot product with the 3rd vector. The ordering doesn't matter. Because look, this is 3 vectors represent the box in the 3 dimensions. So actually we have 3 vectors, suppose, and we have a box like that. Let me see, let me try to do my best. This represents a box like that, box. And the volume, so the interpretation of this triplet scalar product is the volume. Well, actually the actual value of this represents the volume of this box. If the point are coplanar, entonces the box do not exist because it's totally flat, and you prove that. This is one possibility. Another possibility is set up the determinant formed by the vector. It's the same in other view, and you convert the problem in a pre-calculus problem. Okay, this triplet product, scalar product, is equivalent to this. Of course, the absolute value of this, because the determinant may be positive or negative. No, I don't care, because volume is volume. It's a space. But let's do it by this way. I don't know why I want to practice a little bit. U cross B. U cross B is the classical algorithm that we start the first day. This is the mnemonic device, no? To remember the formula. IJK unit vector orthogonal. You copy the component is 1, 4, -7, 2, -1, and 4. Okay, you copy the first vector in the first row and the second row, no? And you copy the second vector in the third row, because the first row is the classical IJK vector, no? Entonces, well, one more time I do it by hand this. Okay, I'm bored to do that. Okay, but I promise that throughout the course, we're doing this 1,000 times. But this is important, you know that, right? You mentally delete the row que contain I and the column que contain I, and stay alive for -7, -1, and 4. The second cofactor is always negative. So the first is positive, the second is negative, and the third is positive. Entonces, you select the red row when you delete mentally the second column on the first row. No? Entonces, stay alive 1, -7, 2, 4. Okay. Entonces, 1, 4, 2, -1. Okay. When you multiplication, this is 16. 4 times 4, 16. Entonces we have 3 negative. Remember, when you multiply in this direction, it's negative. When you multiply in this direction, no negative, it's positive. 16 minus 7, and minus 7 is 9. 9i. Minus, well, this is 4. And this is 14, no? 14, pero el doble minus become positive, entonces es 18. Pero this negative stay. And 18j. And this case is -1. And this case is -8. Entonces es -9. Okay. If you want to express the vector, I like that way. If you express it like that, 9, -18, -9. Using angular bracket, no, in this Hamilton notation, no, separated by IJK. I like this way. Okay, finally, I am doing the dot product. Look at the formula. I did that part. Dot product W is basically 9, -18, -9. Dot product 5, the third vector. I never use it. I use it now. 9, -4. Entonces you multiply component by component, 45. Welcome from 45, 9 times 5, no? And -18 times 9 is minus 162. And finally, 9 and 4 is positive 36. And the answer is -81. I don't care the sign, because you take the actual value of this. Actual value is 81. And this represents the volume for the box, the hypothetical box formed by the 3 vectors. This yellow part is 81, I don't know, cubic unit, a liter or cubic meter, whatever. Entonces es obvio que the box exists. Si the box existe, entonces the points are no coplanar. And this is the final answer, no coplanar. Coplanar. See, the answer is 0. Nice. The box is totally flat, do not exist, and the point are coupled. Any question? Any question? Any question? Any question? Come on. This is a moment. I don't want this become like a monologue. I am speaking, and you are quiet. No. Any question? Are you feel strong? No question, Professor. Annette Cruz is no question. Okay. Okay. Let me try the question 10. See. Guys, let me say something. I suppose we finish today. I suppose. Si we don't finish, no problem, we continue Friday. This Monday, next Monday, we have no school. Okay? It's holiday. I don't know. Bueno, es holiday. Okay? Entonces, don't expect que I won't send any email. Memorial. Thank you. Memorial Day. I won't send any link for the connection. No, because I am the beach. Taking my holiday. I will enjoy my holiday. Okay? Entonces no link, no lecture. You take advantage. Bueno, I am the beach. You don't. You continue working in the homework. Okay, entonces suppose do a sketch C equal x squared. What do you think about this surface? What kind of surface? Classification is. What kind? What's the name? It's plane. No plane, Giraldo. Why no? Because a square indicates que it's no plane. See, I agree with you si es x equal C equal x. Cuando es linear, it's a plane. When it's non-linear, impossible to be a plane. So the clue que give me information que it's no plane is because it's a square. Or another power que different to the one, cubic. This is no. Entonces, what kind? No plane. Es surface. Surface is a little bit curvy. Okay? But what kind? Ellipsoid, hyperboloid one sheet. I have no idea. I'm totally lost. I never remember that. But I need to remember that. Okay? I need to remember that. Parábola. Parábola is in 2 dimensions, Ricardo. Parábola is in 2 dimensions. I agree with you. Que, exactly, Restrepo. Okay. Everyone saw que ese parábola should be parabolic. Okay, ese. Entonces cilindro parabolic, parabolic cilindro, whatever you want. You put the first name, last name, parabolic. Es parabolic, pero es cilindro. How do you know que es cilindro? What is the clue que give me information que es cilindro? First name, last name. Because one variable is missing. Okay. Listen to me. This is the last time I explain this idea. Es obvio que en the XZ plane, when the Y is omit, Y is the axis que in this case is perpendicular to the Y bar. This is the parabola. Open up, right? But I know in 3D, 2D picture. In 3D picture, Ricardo, 3D, we have the famous, okay, this is X, this is C, and this is Y, no? We have this parabola. Okay, let me use another color, no? It's exactly the same like that. This parabola is exactly the same I try to do here. But when the Y is missing, it's because this is repeated. Okay, entonces this look like something like that. All right, let me try to do my best. It's like a one piece of paper, okay, blend like that. Got it? Do you understand this or no? Any question? Any question? Any question? Wow, your 3D drawing skill are amazing. No, hello. No. I am too bad doing that. You put in the algebra, right? And you see clear, super clear. Okay, good. Next question, 11. No problema, guy. Everyone understand 10? 10 is easy. Uh-huh. Number 11, no? 11. 11 is 11. It's long. This is the problem here. It's long. It's sine t. Okay, sorry. There's a one vector value function is given. Position vector is sine t, comma, cosine t, comma, natural logarithm absolute value, secant t, secant of t. This is the vector value function. And they want, the question say, compute the curvature in 0. This is good because more complicated curvature to any time expression. But I take advantage que es 0, yo evaluate 0. Pero no, of course, in order to find the derivative, no evaluate 0, no, because derivative 0 is constant, entonces it's totally wrong. So you start differentiation. You compute the velocity first derivative. Derivative sine, cosine. Derivative cosine is minus sine. And derivative this is a little bit weird, but you're using the chain rule. In the chain rule, you differentiate. Let me try to do it here. Derivative with respect to the time of the function calculus 1, natural logarithm, absolute value, secant t. Okay, so you differentiate the natural logarithm first. You start for the outermost function. It's 1 over. It's reciprocal, no? You remember that the derivative with respect to x of the natural logarithm of x is 1 over x, no? Reciprocal. Reciprocal what is secant, no? Secant. Multiplication, chain rule, derivative the argument is secant, and secant is secant time. Es obvio que secant cancel out and stay only alive tangent. Tangent t. Everyone follow me? Entonces I take advantage. Look, I take advantage in this moment. And also I know, evaluate at the point that they want to find the curvature. In this case, 0. Because I try to evaluate. Look, so you evaluate here. Position vector en 0 es igual. Bueno, sine 0 es... Bueno, no. This is not necessary. No. You evaluate the velocity en 0. Cosine 0 es 1. Sine 0, I don't care que es negative, 0. Tangent 0, 0. Remember the formula for the curvature. I want to copy one more time. The formula for the curvature is a constant, it's a numerical value. Is r prime cross r double prime, magnitude of this, divided by r prime, absolute value raised to the cube. This is the famous formula that we use in the homework online several times. Okay, entonces I need to compute double prime, que es acceleration. Acceleration is, derivative cosine is minus sine. Derivative sign is minus cosine. Derivative sign is cosine, positive cosine, but we have minus in the front, it's also negative cosine. And derivative tangent is secant squared. T. Now you evaluate R double prime is 0. Sine 0 is 0. Cosine 0 is 1, pero es negative 1. And secant is the reciprocal of cosine. Cosine is 0 is 1. Reciprocal 1 is 1. Square is 1, plus 2. Okay, super. Entonces, my goal is now, why not, find the cross product. Entonces, cross product of this. Of course, I try to find magnitude of this. But first of all, cross product. Of course, I using the vector value function using t? No, because I want the curvature specific and 0 at t equals 0. So using the easy way is find ijk using the vector 1, 0, 0, 0, negative 1, 1. Okay? Okay, one more time. I am bored to do that. I is 0, 0, negative 1, 1. Minus j, 1, 0, let me see, 1, 0, 0, 1, good. Plus k, is 1, 0, 0, negative 1. Let me check it just in case I make a mistake or not. Yeah, it's good. When one row or column of the determinant is 0, it's obvious that the entire determinant is 0. So we have no 0i. Minus, this is 1. Minus j, 1j. Plus or minus, I don't know, es negative k. Okay, entonces the vector is 0, negative 1, negative 1. This is my vector que corresponde cross product between R prime and cross R double prime, evaluating 0. But the magnitude of this, it's obvious that the magnitude is square root 0 square plus negative 1 square plus negative 1 square. Bueno, es 2 radical 2. That's radical 2. And that's it, no, I need to find now the magnitude of the velocity we have here. Look, magnitude of the velocity at 0, of course, is 1. It's obvious que 1 because we have only one component. And 1 raised to the cubic power is 1. So the curvature is equal at 0, of course. Sorry. At t equals 0. Another value, no. Is radical 2 over 1 cubic. Is radical 2. End the story. I finish. In my opinion, this is the easy way. There are many several ways to do that. However, this is the easy way. That was the question number 11. Okay. Now 12. Okay, and the question 12. Any question, guys, about curvature? It's clear or confusing? I suppose that when you finish the homework online and the test no, but the homework online, ask you frequently curvature and different functions. Okay, let me try number one. What number is this now? Next is number 12. It's a find the line which is containing in the plane. And also it's perpendicular to the. Okay, what's that? Find the line which is containing in the plane. So we have a plane. The one plane is given 12. Number 12 question. Okay, one plane is given, which is x plus y. minus 3z equals something. I don't see clear. Equal in my paper I 7. This is the plane. It's a plane. Equation of the plane. I suppose. Entonces now it's perpendicular to the intersecting line. Wow, what the hell is that? We have a line x equal triplet 5t, y equal 2 minus 4t, and z equal minus 2 plus t. Well, I have no idea. Is this a line? It's a parametric equation for the line. I suppose we have different possibility of the line. Maybe the most frequently possibility is que siga, o touch in one point. I don't know if it's possible. So what is my goal? My goal is you find the line que is containing in the plane and also is perpendicular to the intersecting line, which, okay, if we need to find the equation for another line containing in the plane, and this is perpendicular, and it's a perpendicular. Okay, I need to find the equation for the red line to satisfy some condition. Number one condition is contained in the plane, in that plane, and it's perpendicular to this line. Perpendicular. Okay, so let me try to write here. This is a complicated problem, and a complicated problem normally I need to set out strategy. Okay, number one step is find the point, or the potential point. Find the point. What point? The point in which the line is given. Let me call line 1. This is the line 1. Intersecting or no the plane. So you need to find this point. Let me call, I have an idea, P. The point P. Find P. Okay, when you have P in my hand, well, I need to find, remember the two pieces of information that we need to define a new line. So we have a line 2. The line 2 is my problem. I need two pieces of information. We need the point. Well, actually, I have, because P is a common point between the line 1, the line 2, and the plane. The point is given. I have in my hand. The only information that we need is direction vector. This direction vector. We need this direction vector. We need this direction vector. B. Okay, we have not this vector. We have the direction vector of the given line, is this. Let me call W. Okay, this direction vector is, well, 5, -4, and 1. Okay, the component que have T in my parametric equation for the line. However, we have also the normal vector. Normal vector is the vector 1, 1, -3. Que es the normal vector que es in that direction. Normal vector. However, I know that the problem says that they are perpendicular. Well, no, basically, it's perpendicular to this line. Therefore, in order to find the B vector, I propose you perform the dot product, the cross product, because I know that the cross product between two vectors is a new vector that is perpendicular to the two original vectors. So you perform B cross W cross M, doesn't matter the order. Well, the order, yeah, matter, but doesn't affect my answer, because you find B or you find minus B. Doesn't matter, minus B. So the second step in my strategy, the second step is find W, find B vector. How? Well, perform the cross product between the direction vector of the line, the given line, and the normal vector for the given plane. Entonces, when you have two pieces of information, I might have P and direction vector. Oh, I am ready to determine the equation for the line. Do you understand this or no? Guys, it's important. I recommend the complicated problems, you analyze strategy, and you copy step by step. In this case, 2 steps. But in another more complicated cases, more complicated problems, we have several steps. Okay, so my goal is, first of all, find the famous P point. To find the P point, the only thing you should do is substitution this equation into the plane. So no x anymore. No. It's 3 plus 5t. Plus, no y anymore. It's 2 minus 4t. Minus 3 times minus 2 plus t should be 7. And solve for t. We have possibility. When you try, we have no solution. That means it's parallel. Si it's parallel, have no sense in that problem. But in this case, yes, we have solution. It's 3 plus 5t, remove the parenthesis, plus 2 minus 4t, plus 6 minus 3t, equals 7. It's solving this equation. This is t, this is 5, 1 minus 2, no? Minus 2t, equal, let's say we have 7, minus 6, minus 2, minus 3, no? This is 9, this is 1, this is 1 minus 2, minus 6, no? Minus 6, no, minus 6. Okay, it's negative 4. Thank you. Bar by negative 2 is 2. Yeah, because it's 1, minus 2 is, it's negative 1, and negative 1 minus 3 is negative 4. It's equal to, entonces, okay, nice. When you get the number, it's because the line 1, is the black line, intersecting the plane. At what point? Well, you find x, y, and z. How? You plug it in t equal to, and the line 1 equation is 3 plus 5 times 2t, que es 2, is 13, no? 13. Y is equal to minus 4 times 2. Is minus 6. And z is equal, well, it's minus 2 plus 2. It's 0. Wow, it's 0. Entonces, the famous point P is the point 13, negative 6, 6. Boom. Okay, I finished that part. Okay, now the complicated part, or the long part, not complicated, long part, is I have in my hand the vector W and the vector normal vector for the plane. I perform the dot product. So it's W vector cross product and vector. IJK is 5, negative 4, 1, 1, 1, negative 3. Guys, I skipped that part. I am bored to do that. The answer is 11, 16, 9. Okay, I am ready. I am ready to write the final answer. The final answer is the parametric equation for the red line is x, y, z. The point is obvious, guys. 13, negative 6, 0. 13, negative 6, 0, no? Get this point. Plus something. Direction vector. 11, 16, 9. 11t. 16t. 90. End the story. This is the answer I want to find. Of course, you can simplification a little bit if you want. Okay, 0, this 0 not necessarily right. So it's x equal 13 plus 11t. Y is equal minus 6 plus 16t. And C is just 90. Not really, not necessarily 0. Any question, right? Okay. The question, next question 13 is find the shortest distance between the point P 1, 2, 3 and the line is given by the vectorial equation. Okay. Okay, 13. Any question in 12? Do you understand this or it look like complicated? Okay. Yeah, it's a little bit sophisticated, yeah. It's a little bit sophisticated. I understand. Okay, normally in the course face-to-face, it's different. When the course is face-to-face, the test is similar, but we have no online test. We have homework, only homework. And face-to-face different. We have homework online, and we have tests on paper in front of me, face-to-face. But I present 10 questions, but you need to solve it only 5 because it's limited time, only 5. And the rest, you can do that. So you have time, because you are advanced student, it's extra credit, 10 points extra for each. Sí, 10. Pero online is always is a little bit hard, is because you have no problem with the time. No? Okay, entonces the question 13. 13 is classical, no sophisticated. Okay, we have a point, is the point 1, 2, 3. We have a line, the line is given, que en parametry is 4 plus t, y 5, and c is 6 plus 2t. Let me check it just in case. Okay, let me check it just in case. Yeah, 4 or 5. So basically, if you want to express it like a vector value function, okay, this is the vector 4, 5, 6. So another way to express t is a parameter, and the parameter here is 1, 0, and 2, because we have no t here, it's missing. This is another way. I like so much parametric. The vector function is like that or like that. 4 plus t, comma, 5 alone, no t, comma, 6 plus 2t. Entonces, what is the idea? Well, the idea is, I don't know, shorter distance. What I mean to be shorter distance is this distance between, look, we have a point. Let me try to make a sketch. This is a point, 1, 2, 3, 1, 2, 3. We have a line, I suppose hypothetical, like that, this line. I need to find the shorter distance. Okay, no, not good. Shorter distance. It's perpendicular. 90 degrees. Shorter distance. Okay. Entonces, I have two possibilities. Or using the formula or using the imagination. For example, I determine 1 point on the line. Okay, why I determine 1 point on the line? Okay, I call Q here. Q. I call Q. And this point, for example, the easy way is you suppose T0. And T0, the point is the point Q is 4, 5, 6. Okay, guess when the t is 0, disappear the t part and stay only 4, 5, 6, no? And you determine why now. You determine why now that vector. I want to call PQ. Oh, no. In this case, no PQ. It doesn't matter. The QP. QP, the notation normally is the arrow on S and P. But it doesn't matter if it's in that direction or that direction. Okay? PQ is the vector. Que es subtraction is 1 minus 4 is negative 3. 2 minus 5 is negative 3. Wow. And 3 minus 6 is negative 3. It's a vector negative 3, negative 3, negative 3. It's a coincidence. I don't do it intentional. I didn't intentional. Okay. Now, how you find the blue distance? It's a projection, no? It's a projection. What kind of projection? Horizontal projection or vertical projection? Horizontal projection or vertical projection? I have no idea. Okay, the only thing I have in my hand is the direction vector, B. The direction vector of the line is 1, 0, 2. Okay, by the way, this vector lie on the line in any position, so you want to put here, and you perform, entonces the orientation of this green vector and the blue segment I want to find, or I need to find, is perpendicular. Entonces es obvio que we are using the vertical projection, not horizontal. Okay, makes sense or no? Makes sense or no? So basically, I need to perform the cross product, because vertical projection is using cross product, and between QB vector and B. Pero no B, sino uni B. So you need to find first the ball. Okay, here I copy B vector. Okay, it's a vector 1, 0, 2. And you find the uni vector of B. Okay, by the way, the magnitude of this B is radical phi, no? It's 1 squared plus 0 squared plus 2 squared, radical phi. You divide by radical phi. Entonces, the unit vector is 1 over radical phi, 0, 2 radical phi. Radical phi. And you perform the cross product between QP, cross product, unit vector B. Guys, remember, in the projection, regardless si es horizontal projection or vertical projection, we always using unit vector. So you are doing the cross product between QP and B, no. It's using unit vector. So you need to determine si es vertical projection or horizontal projection. It's vertical because the location, you see the position, and between the green vector, que es the direction vector of the line, and the segment I want to find is perpendicular to the vertical. So basically, the thing I am doing is the cross product. Let me set up the cross product and the mathematical part I omit. Look, IJK, minus 3, minus 3, minus 3, que es the component for the QP, and the unit vector is 1 over radical 2. Radical phi, coño. Radical phi, 0 and 2 over radical phi. Of course, I skip this part. I'm boring to do that. And the answer is negative 6 over radical phi, comma, 3 over radical phi, comma, 3 over radical phi. Okay, and what's the answer? Because the answer I try to find is distance. Well, you find the magnitude of this, and also the actual value. So the magnitude is square root minus 6 over radical phi square plus 3 over radical phi square plus again 3 over radical 5 squared. Magnitude of this. Entonces this is 36 over 5, this is 9 over 5, this is 9 over 5. When you put everything together, it's 54 over 5. You approximately round decimal approximation 3.286. Boom. Done. This is short distance and between the point is given underline. Any question? What part you don't understand very well? What part you don't understand very well? Come on, guy. Come on, come on, come on, come on. This is the last part. Okay, we have another problem, no? But we have no time. Okay, so now, next time, Friday, we finish the last problem and we start new chapter. Let me try to record something.